I've been involved with this thing called identity server for quite a while, and as the name implies, it's a server. Yeah, and I never really cared about clients, but I also completely appreciate the fact that most people, the only reason people bring up a server is to connect clients to it. So we have lots of customers that actually write clients, and what this talk is about is basically giving you an overview, basically, of the things you need to know when writing a client for a token-based backend, and that is typically OpenID Connect and OAuth. Okay? This is not an introduction to OpenID Connect or OAuth, otherwise we would need 2 more days after this session. So the assumption is that you kind of know what it's about, and and you basically just get the guidance, the digest, if you like. Yeah. So when you start going out to the internet and Google for how do I build a client for OpenID Connect, yeah, you're gonna get tons of links, basically, yeah, and part of that reason why you're gonna get tons of links and also maybe confusing and conflicting information is because it's complicated. Okay, and one reason it's complicated, more complicated than it could be, is that OAuth and OpenID Connect are maintained by 2 different standards bodies. Okay. Normally, you don't use OAuth on your own, or on its own, rather, and you don't use OpenID Connect on its own. It's typically a combination of the 2 protocols that make up a useful system. The problem is that one is maintained by the IETF and one is maintained by the OpenID Foundation. And you have to basically piece together the information from both websites into one guideline, if you like. Okay? So if I go to these websites here and transform the content into this, it gets apparent that there are a significant number of specifications out there. Yeah? I recently saw that somebody counted the pages of all specifications, and it was twice the number of pages than War and Peace. So it's a lot of stuff to read. Okay? Unfortunately, I can tell you I have read them all, I guess. So what this talk is about basically is sorting out the useful versus the not so useful stuff. Okay. So normally we talk about the things on the right side. Today we're going to talk about the things on the left side, and we will make a distinction between so-called public clients and confidential clients. Yeah. So when you look in the spec. The definition of a confidential client is a client that can securely store a secret, and that, for all practical means, typically means it's a server-based client. Yeah, something that lives on a server that is secured in a data center, and you can store stuff there. Yeah. Whereas the public client is exactly the opposite of that. It's basically something that is that cannot store a secret securely. Because there is no good place to store it, yeah, like JavaScript-based applications or things that you install on users' machines. Okay, so we're going to have a distinction between the 2. So generally speaking, regardless of the client, yeah, the requirements look simple, right? You get a token, you use the token. That's the whole point of the system. When we look at the most simplest flow in OAuth, which is called the client credentials flow, which is for server-to-server-based communication, the way this works is basically this. You have a client, that's this thing here. You have APIs in your system, and you have this thing called the authorization server, which is basically the token service. So when the client now wants to talk to the API, he doesn't send his secret directly to the API. He first goes to the token server, authenticates if the token server, gets back a token, and from that point on uses the token to access the API, right? That is the way it works all the time in variations. Sending the token to the API, there's a spec for that, RFC 6750. Basically, the recommendation is use the authorization header in HTTP. That's a special header from a security point of view. Web servers are aware of this header, that it will contain confidential information. They typically don't lock these headers. Browsers handle them in a special way, and so on. So that's basically how you send the token to the API. So that's easy, but the hard part, and that's probably the biggest part of this talk, is what's happening in between after you requested the token and before you use the token. You have to manage those tokens. Yeah. So what you don't want to do is for each API call get a new token. That would be very inefficient. Yeah. So what the typical approach is you get a token, you store it somewhere, you hold on to this token for a certain amount of time, and you keep using or reusing that token to talk to the API. Okay? So there are many approaches on how to do that. You know, like maybe just storing it in a variable is good enough, or maybe you have like a real caching system. ASP.NET has this session storage system. Maybe you have more, you know, like a vault, for example. Things like that. A database might do as well. And then there are two general strategies here. Either you just, you know, put that thing into cache, maybe give that cache a lifetime of token lifetime minus 1 minute or 2 minutes or something like this. And as soon as the cache doesn't give you back the token, you get a new one, cache it again, and continue using that. The other approach is called, you know, is more like you don't care too much about the caching. You just keep using that token until you get back a 401. 401 means, well, the token is expired. You get a new token, you resend the request. So it's more, you know, it's proactive versus reactive. One of the two you have to implement. Okay, so in other words, the real challenges are requesting the token, well, but which type of protocol flow we are using, managing the tokens, storing them, renewing them, you know, make up your mind for how long you need to access those APIs, and then you use the token. So that's, you know, that's how it works. Okay, so let's have a look at some typical scenarios here. Yeah, so one is or the most common scenario, I should say, is basically you have an interactive application, you know, with a UI. Let's say it's a web application. So you have a couple of jobs to do here. You want to authenticate the user first, so you want to know who the user is. You want to probably start a session or join a session, like a single sign-on session, for example. You know, there are some other things here related to the session, like listening for session end notifications and so on. And then you want to make calls to APIs on behalf of that currently logged on user. And then you want to manage the token, basically that for the lifetime this user is using the application, you know, you are actually able to call these APIs because they expire at some point and you need to manage them. So for that, the original OAuth specification has created this thing called the authorization code flow. And the idea of the authorization code flow is it's a two-step process. The first step is coordinating all of the UI work, and the second step is then getting the tokens. So the UI work happens on the front channel in the browser typically, where you go to the authorized endpoint and you say, okay, I want to have access to these things. Give me a code that represents the outcome of this request, so that then afterwards I can on the back channel, you know, exchange that code with the token. That's authorization code flow, and you know, this is not an introduction to OAuth. The assumption is you know all these things already. Okay, so that flow was created in the first place because it seemed to be the most secure option, right? So if an attacker could steal the code in the browser, then he couldn't turn it back into a token because he's missing the client secret, for example. So that, you know, was the original motivation, so to speak, that this code represents all the things that happened in the UI, and then the back end, with including that client secret, then can harvest the results, so to speak. Yeah? So that code flow is from 2012. That was when the OAuth spec was created. It turns out attackers are, you know, they have some good ideas. And they try to attack this protocol in a way that nobody thought about it first, yeah. And you know, and this is called a code substitution attack. And the idea is this, yeah. Yes, the application, an attacker cannot turn that code into a token because he doesn't know the client secret. But if I can trick the application into turning a stolen code into a token, then, well, I don't need that client secret because the application is doing it for me, right? So the idea is maybe I make Brock click on a, you know, install a malicious application, for example. He logs in, returns a code. I'm stealing that code from him. Then I'm logging into the real application, and on the way back, I just exchange my code with the stolen code, and I'm impersonating Brock, right? So it turns out OAuth has no mitigation technique for that. Yeah, so the original code flow is vulnerable to this problem, and there is no solution for that in OAuth itself. That's why additional specs exist, and you should use one of them. One is more like the OpenID Connect flavor of solving that problem, and one is more the OAuth flavor of solving that problem. And it depends which flavor your client library supports. Okay, so one of the two should be in there. So let's start with the hybrid flow. And what the hybrid flow approach is doing is basically he adds another token to it, yeah? Well, because ultimately the problem why the client cannot make sure that code is really the code he was looking for is because he can't validate it, right? But with an ID token, you can validate the identity token, and then inside the identity token, there is a special claim called the C hash, which is the hash of the code. So in other words, you first validate the signature of the identity token, and with that, you can validate the signature of the code, okay? And that, makes sure that this code is actually belonging to the identity token, and that means nobody has substituted it, okay? So ASP.NET Core is an example of that, where this is implemented, for example, yeah? Yes, ASP.NET Core. So when you are using ASP.NET Core as a client, you are in a pretty good state because their client library is very good. Yeah? They support hybrid flow, they support all the crypto stuff. It's a good library. We can, I can briefly show you that. That's the example of an ASP.NET Core application. That's their OpenID Connect handler. You basically specify, okay, the response type is code ID token. That tells the handler, okay, I'm going to use hybrid flow. I'm going to do all of the extra security checks, and that's all being done for you, okay? Another thing that ASP.NET Core does it has facilities for managing the tokens or making the token management easier. I showed this demo this morning already, so I won't go into detail, but basically you can hook into the session lifetime events at ASP.NET Core and implement your token management there so that your actual business code doesn't need to do this, okay? And that's basically by implementing a couple of events here on this cookie authentication handler, and one of them is called validate principal. So when the cookie comes in, we look for the token in the session. We check, like, is it about to expire? If that's the case, under the covers, we're going to refresh that token, exchange the old one with the new one. Your application code doesn't know about this because it's all happening kind of like in the pipeline. Okay. The other thing you can do is, which is good hygiene, at sign out time, we are actually revoking the token again, right? Because that's a good thing to do. As I said, we don't have time really to go into all these details, but all of these samples are in our GitHub repo, and I'll show you the URL later so you can play around with that code. Okay. There are always issues, right? So you could think like, okay, hybrid flow is the solution to the problem, so why do we even continue thinking about this problem? It turns out that the solution that hybrid flow proposes is not simple to implement. Okay, so as I said, if you're using ASP.NET Core, then you're in a pretty good shape. I have many customers that have to integrate with other companies, and they don't use ASP.NET Core. They use PHP and Java and so on. And it turns out it's not easy to find spec-compliant hybrid flow implementations outside the Microsoft space because they implemented it, but many other libraries don't. Yeah, they just stayed on pure code flow, ignoring the problem with the substitution. Yeah, so that's one thing. Yeah, it's harder to implement. The other thing, there's another spec that came after OpenID Connect. It's called GDPR. You might have heard of that one as well. Yeah. Since in hybrid flow you are sending an identity token, you are potentially leaking identity information over the browser, right? Because that's the nature of the identity token. Depending on how good your subject identifiers are, or bad, how bad they are, you might leak identity information about the user, and that might get flagged depending on who your GDPR consultant is. Yeah. So the nice thing about the code was that all you're really sending over the front channel is this random number, and that's it. There's no information in it, so to speak, but it's not good enough. Yeah. And we'll see a second technique in a second. Okay. Let's switch to public clients. So for public clients, we typically deal with two fundamental types. One is native clients, like a phone, phone apps or desktop apps, and JavaScript clients. Yeah. So when we look at public clients, the rules are a little bit different here. So normally, when we see confidential clients, there's a one-to-one mapping between a client ID and the instance of a software. Yeah? Whereas with public clients, basically, you're creating your mobile client, you give it a client ID, you put it in the App Store, 1 million people download it, they all have the same client ID. Okay, so that's different. There is a process called dynamic client registration, which basically is a way to how you can turn a public client into a confidential client, and that is typically done for, if it's done, then it only makes sense for mobile, for native apps. And the idea is this, that basically you are putting your app into the App Store with a bootstrap client ID, and then it's downloaded the first time you run it. There's some sort of user authentication happening that's pairing that instance of the client with some backend. You issue a new client ID, you issue a client secret, and then you have a confidential client, basically. Yeah? But that is rarely done, to be honest. Yeah? Okay. The good thing is, if you're building a native application, then there is actually a spec for that, or a spec is maybe the wrong word. They call it a best current practice, yeah, and it basically is a guideline, if you like, yeah. And again, you see it's funny that they call it OAuth for native apps and not OpenID Connect for native apps because it's written by the IETF and not by the OpenID Foundation. But guess what? All of the reference implementations of that spec, they live on the GitHub repo of the OpenID Foundation. And guess what they do in their reference implementation? They do OpenID Connect and not OAuth. Yeah, so it's all a bit silly. Apart from that, this is a very good document to read. It's very practical. It's been written just a year ago, I think. And it talks about actual features of mobile operating systems like iOS and Android, and how to use them to create better applications. So the first thing they talk about is how you should not do things. And that is basically by using a native login page. Yeah? So you know all that. You install an app, it brings up a native login page with name and password, and then you think like, okay, so what are they doing with my password now? Yeah, is that secure or not? I don't know. But generally speaking, the spec tries to discourage you from using this flow here, where you harvest passwords in the front end, send them to the token service, right, and then use the resulting token to call the API. And to be honest, in all fairness, this is much better than it used to be, where the app just harvested the password and just sent it to the API directly, right? I mean, that's an improvement. The problem is you don't know how good this developer was, really. Like, is he really throwing away your password? Is he really storing these tokens securely? Yeah, I don't know. Do an experiment. Yeah, if you have an iPhone, you can do a backup of your iPhone. And there are two backups. One is the application data backup, and one is the keychain backup. Okay. Normally, all your secrets should only live in the keychain and not in the application space. Yeah. So, and then restore that backup on a new phone and see how many applications you are still signed in. Okay. If you're still signed into applications, then their developers, they stored your secrets just somewhere on the hard disk and not in any secure location. And they might probably even have your password and so on and so forth. So, I don't know. I don't like this approach, but if it's a first-party application, it's hard to argue against it. If you own the front end, you own the back end. It's a business decision typically. What I prefer from a technical point of view is this approach, where where the client opens a browser, so to speak. It goes to your already existing login page where you have all your logic already in place, right? You log in there, and there are techniques to transport the tokens back from the browser back into your application. Before we actually talk about these techniques, I can show it to you, yeah, just to see how it feels. So that's an iPhone, apparently. So Apple provides native APIs to launch a special browser. It's a special browser specifically made for authentication. Yeah, it has a couple of features. It is secured against a key logging, for example, so the application cannot read the keystrokes from that browser. There is some, memory protection there, and you also get access to the shared cookie container on the phone. Meaning, if you already have a log-on session with the browser on the phone, you can reuse that log-on session also from within the application. So when I click that, and because it's a special API that is only used for authentication purposes, Apple will tell you, regardless of what the application just told you, that the window that will open now is used for authentication. Okay, and that's basically a mitigation against phishing attacks and so on. Okay, you press continue here, then the browser opens. You have your login page here, and since this guy supports Google, and I already have a log-on session with Google on my phone, I think. Let's try it. Yep, that worked. No login page, right? Single sign-on, and then the tokens get sent back to the client application. Okay, and from that point on, I have a refresh token. I can call refresh here, right, and get new access tokens. I can call APIs. And from that point on, this application can run independently and doesn't have to show that browser again and again. So that's a pretty good technique, I think. How does it work? Basically, by registering a special redirect URI with the operating system, and when the browser comes back to this URI, basically what will happen is that the operating system will do a callback back to the application where this URI belongs to. And that's how you get back your code. You open the back channel, get your tokens. Okay. There's one more thing. I mentioned that there's a second technique to mitigate code substitution. It's called PXE, a proof key for code exchange, and that's what's being used here. So basically, what's happening here is before the client application opens that outgoing call, it creates a secret, a random number, basically, which is only used for one single request, and then it hashes that random number and sends it along. Okay, and when it opens the back channel communication, it's gonna send the clear text version of that random number, and what the server is gonna do then is it will take the clear text version, hash it, compare it with the hashed version you got on the front channel, and that's how you can prove that both network legs actually belong together and that you didn't get a code substituted under the covers. Okay? This has exactly the same purpose as hybrid flow, but it's a considerably easier implementation, yeah, because all of the checks happen on the server. They don't have to be done on the client side. And that's why more and more people are leaning towards rather implementing PXE as implementing hybrid flow these days. Okay? So because all you need to do on the client is hash something, send it to the server, and that's it. Right? So yeah, you need to have one of the two. Yeah? Which one you prefer, up to you. Yeah?
Would you say that one is better than the other?
No, the end result is the same. Yeah? Hybrid flow, I think, is mostly designed for server-side applications, whereas PXE can be used everywhere. I think it's the simpler solution to the problem. Okay. 25 minutes only. That's good. We're good on time. So just to show you another application which is not written by me. Yeah, if you need to convince someone that this browser-based login thing is actually not too bad, that's GitHub for desktop. When you download that their assumption is that that if you have this application on your desktop, you probably also have an existing session already with GitHub. Okay? So when you go here to Preferences and say Sign In, You see, basically, they say sign in using your browser. So what they're actually going to do is they're going to now launch the default browser on your machine, which holds all the sessions and the cookies and so on. And then if you're already logged in that browser, you will directly come back with tokens that GitHub Desktop needs to talk to the APIs that they provide. Okay? Okay? Now, the sign-in experience is not as nice as it is, for example, on a phone. You have this dialogue now saying, OK, I'm done, I guess. Do you want to come back to the application that initiated that? And I can see that some people don't like that because maybe a normal user would be confused what's going on here right now. Yeah. What you could do probably is have a nicer page here saying what's going on and why is it OK to click the open link or the open button. Yeah, but they didn't do that. I guess the assumption is developers know what that means. Yeah? Anyways, when I click open, it's basically doing the same thing. The code came back to the client application, and then the client application got the tokens, and then they can call the GitHub APIs. Okay? Or if you're building your next text-based adventure, for example, yeah, and you need authentication, you can also make that work in a console app, right? So all what this thing is really doing is it launches again the default browser and makes you sign in there. Okay, so maybe with Google again. Okay, same behavior, right? You want to go back to whatever Windows console system browser.exe is, but you know, we're developers, right? Makes sense. And then the tokens are back into your console app, right? And then you can start, you know, calling APIs, like you enter a dark cave or things like that. Yeah. So it's a general purpose technique, basically to rather use a server rendered login page than a client rendered login page. Okay. Good. What is to say about token management here? Well, it's pretty much the same as on the server, right? You should store those tokens somewhere secure. Every operating system has typically built-in secure data storage mechanism like Keychain on iOS or DPAPI on Windows, or there's something on Android which I don't know the name of. You have to, again, manage your refresh tokens. You know, same idea. You keep the refresh token somewhere secure. If the token expires, you get a new access token by the refresh token, and you know that's how the client keeps itself alive. And same idea is at logout or uninstall time of the application, you probably should revoke those tokens so that they are properly been cleaned up. Okay? So, oh yeah, client libraries. The people that wrote the spec, the RFC, they have two reference implementations of that, one for iOS, one for Android, and they're native, like written in Java and Objective-C. And the one I just showed you is a .NET Standard library. It's written in C#, and it works on multiple flavors of .NET. Okay, so now the big elephant in the room here is browser-based applications, because they have some special considerations, okay? And that guidance has recently changed, and there's a new spec here, which is basically has the same purpose as the OAuth for native apps. They want to have an OAuth for browser-based apps, and Brock and I have been working hard for the last weeks to update the course material, update the client libraries, update everything to reflect this new guidance. So Brock will show you what is this all about. Which is, we're doing this thing that you probably should never do, like switching laptops in the middle of a presentation, but you know, we'll see. We're here, we're professionals.
All right. Oh, good, the mic's on. It's a good start. That looks scary. Okay, good. Excellent. Oh, no, don't do that. All right. So yeah, the last type of client application that we're going to look at is the notion of a JavaScript browser-based application. And as Dominic mentioned, it's the elephant in the room because it's really the hardest scenario to secure. But they are, as it says up there, the most popular type of application, right? All the people building Angular apps and React apps and things like that. So the reason it's one of the hardest scenarios to secure is because that browser is a shared execution context, right? You'll open up a tab and you go to one application, you open up another tab, you go to another application, and they're sharing the context of that browser. So that makes this actually a really hostile environment because you could be in a good app, and then in the bad app is running code in the browser and is doing attacks against the good app. These two most common types of attacks, cross-site request forgery and cross-site scripting. And basically, these are both about scenarios where from outside of your good application, a malicious app is somehow triggering requests into your good app. The cross-site request forgery is trying to take advantage of submitting data into your application or extracting data and leveraging the user's authentication session in the good application. Cross-site scripting is where from outside, code is injected into your application. And both of those, obviously, are not good. So as Dominick showed all the specs and all the evolutions of the specifications around OAuth and an OpenID Connect, basically what was happening is, they would put out one of those specs. It was like a starting point for guidance on how to do something, and then somebody would discover a problem or a vulnerability, and they would then put out a new spec to try to fix it or patch it up. And so Dominick mentioned the best practice document for native apps, mobile apps. So we've been wanting something like that for a long time for JavaScript applications, and they just would never, no one would ever actually, take up the charge and actually do the work involved with writing one of these documents. But finally, someone did that. And so they're in the process, the IETF is in the process of updating their guidance or providing a guidance document for these JavaScript browser-based applications. So it's sort of been a long time coming. So before OAuth, though, right, to just kind of look at a little bit of history of how we were securing web API calls from JavaScript, before OAuth, which is now 8 or 9 years, the kind of application that you might have built that had JavaScript calling APIs was probably more like a server-side application, right? I mean, I think 10 or 15 years ago, I was doing like ASP.NET, and it was a server-rendered application. And then you learned about jQuery, and you're like, wow, I can do cool things in JavaScript, and then actually make my page a little bit more interactive without using I don't know, the update panel or something like that. And so the idea is that to get logged into the application in the first place, you needed a cookie because it was a server-rendered application. And so the beauty about cookies is that if you make JavaScript calls, AJAX calls back to your endpoints, the cookie is automatically sent. Okay? That's beautiful. We loved it because we didn't have to think about trying to authenticate those calls. So that's basically where the problem lies, is that the cookie is automatically sent on every request implicitly by the browser, and that's actually what that cross-site request forgery attack is taking advantage of. Right? You open up the bad app in another tab, and they start making requests across that boundary, and the cookie will be sent, and your good app's server-side code doesn't know which app was making the request. So there are mitigations for this. For the typical server-side application, like your older ASP.NET, or even MVC, MV5, for example, the anti-forgery style, right, was the typical mitigation against that. So it's very easy to add in, and all the templates have that kind of built in now for ASP.NET Core as well, even. But the problem is most often there was nothing in the templates, or nobody educated you on how to do it for your JavaScript calls. So if you have the scenario where you have normal postbacks, you're probably protected against cross-site request forgery, but are you sure that you're protected on all your AJAX calls? Okay? So very often we do code reviews for people, and we see that they're missing it for the AJAX endpoints. Okay? That's an open problem. Okay? So like I said, this is sort of the biggest problem with cookies for authentication, is this cross-site request forgery attack. Okay? All right. So OAuth was then being developed as a way to protect APIs. About 8 or 9 years ago now. And so as part of their whole guidance around, how are we going to do token-based authentication to APIs, they realized, oh, there are these new style of apps that are being developed, which are more and more JavaScript running in the browser and less server-side code. Okay. Now, some people didn't see this coming, right? And this is actually from the IETF archive, email archive, and somebody was like, "Oh, I don't know what this JavaScript thing's all about," and I couldn't Google for it. But I'm glad, and that the IETF or somebody on the OAuth working group, had the foresight to say, hey, we need to secure this new style of application being developed. The problem is, again, if you look at the date there, it's 2011, so that is what 9 years ago. 9 years ago, they had to solve the problem of figuring out how to allow a JavaScript application to get a token and call an API. We talked about code flow, right? Code flow is the one that we talked about is the sort of the user interactive application style to get tokens. But the problem with that is that requires using the token endpoint, okay? And very often your token server would be on a different domain than your JavaScript app. So we can't make these cross-domain AJAX calls because of browser restrictions, okay? So cores didn't exist at that point in time. So basically, the token endpoint as a technique was sort of out of the question. Also, to use the token endpoint, right, we need a client secret, and that doesn't really make sense for a JavaScript-style application. So what the OAuth committee came up with is something called the implicit flow. And the implicit flow is like an optimized version of the code flow, if you will, where we don't have to use the token endpoint. It's a way to get a token back to a front-end application. And so the way it would work is that your JavaScript application would be running in the browser. You would send the user to the authorized endpoint. I don't know if you noticed down here, but the request is now requesting ID token as opposed to a code. Okay? That's basically say, I want a token directly back from the token server. And that's exactly what would happen then. In this implicit flow, the response would come back into the browser. The tokens that you're looking for are being sent in the URL. Okay, and they're being sent after this hash fragment in the URL there. And the ultimate destination for the token is the JavaScript, right? So that makes sense. So we have to hand it somehow back to the JavaScript. And again, this avoids using the token endpoint. So the app doesn't have to make any AJAX calls back to the token server to get tokens. Okay? So that is still officially, or technically, the official guidance on how you would write JavaScript apps to obtain tokens to call APIs. But as we saw with the sort of the chart with all the specs across all the years, right, the guidance changes over time, and that's because we get more and more features out of things like our browsers, and more technologies get developed to help make things like this better. To really do this right, there are a few problems, right? One is that, or one of the biggest complaints is that the token is in the URL. Okay? Now that's why the hash fragment is used, because we don't send those to the server, assuming the browsers actually implement that properly. It's in your, your history. Maybe somebody hits the back arrow and then can see the access token. So there are things you could try to do to fix it up, but it wasn't part of the protocol. You, as the application developer, had to know to go do these extra things. It's a bit of work. Okay. And also, of course, if you're using to deal with this token substitution attack, right? We could do OpenID Connect and do ID token and token. But if you're doing just pure OAuth, again, we didn't have any protection against the token substitution attack. Okay. So anyway, that has been the biggest complaint about the implicit flow really since it was invented, right? Tokens in the URL. But at the same time, it's the best we had given the limitations. So what is then sort of the guidance going forward? Well, the things that have been developed since the original recommendation basically is that CORS has been developed, right? Now pretty much browsers all support CORS. So now we could take advantage of the token endpoint. And Dominick talked about this new thing called PXE, and PXE helps with the code substitution attack. So with the development of those two features, if you will, over the last several years, it's basically put us in a position where we now can do better than what we did before with the implicit flow. So the new guidance that will be coming out from the IETF is basically for SPAs, JavaScript applications, you should be using authorization code flow with PXE. Okay? And that's basically the new guidance going forward. So it's not that the implicit flow is awful and horrible, it's just that we now have a better solution. So if you've been doing implicit flow for the last several years, that's fine, okay? But if you have a token server that supports these new things, then great. Maybe you could switch over and start using them. Okay. So regardless of whichever of those flows you end up using, we come back to the same complications that the other types of clients have to contend with, which is the token management. Where do you store the token, and how do you deal with token renewal, and how do you protect against attacks against those things? So I guess for browser-based applications, this is also why they're kind of a difficult environment to protect, is that they have no fundamental safe storage, if you will, no protected storage like you do on obviously on a server side, but also in sort of these native apps. So you have to store the token somewhere, right? So the common locations are to put the token in session storage, local storage, maybe IndexedDB, but usually those are the first two that I said are the ones where we usually see, session storage or local storage. So of course, the big problem here is that your app is still prone to cross-site scripting attacks, right? And not only your app, but your entire domain. So maybe your app's on some path under your domain, but you have some other part of your app that has cross-site scripting, right? So that's a very large surface to protect against. So cross-site scripting is really the real biggest concern with building SPAs. It's not OAuth and all this stuff, okay? So again, if you do have a cross-site scripting attack somewhere in your app and it can access that storage, an attacker can export the tokens from your app, okay? So how do we protect against this? Okay? Well, there is yet another newer feature in browsers that we can start to take advantage of to help with this, and it's something called content security policy. This is a feature of browsers that allow you to tell your browser that you want to reduce how much JavaScript you'll allow to run. Okay? And basically, it kind of boils down to where you say, I want this block of JavaScript, I'm going to whitelist and allow it to run in my browser, and other sources by default are going to be disabled. Okay? So if you're building a JavaScript application, you really should be leveraging content security policy. Turns out it's really hard though, okay? Because especially if you've not built the app designed around content security policy, depending on the size and complexity of your app, it's really, really hard to retrofit. So there's actually a link down here at the bottom to a video from a couple of researchers from Google, I believe is what they're from. And they basically did an analysis on all the websites and how many out there actually use CSP. And for the ones that did use CSP, and by the way, the number was really small. And the ones that did use CSP, how many were actually had holes in their CSP policies. And one of the common things is that people will use CDNs for their JavaScript, and so very often with a content security policy, you can just whitelist an entire CDN and say, oh yeah, that's where my code runs, right? Or that's where I want it cached from, so let it run in my browser. Well, the problem is the CDN's also a shared environment, and lots of other people are running all kinds of other code up on that CDN. So that's probably not the best approach. Okay? So content security policy is something you should be using, but again, admittedly, it's really hard. There's another specification that was intended to help fix some of these problems as well, and it's called HTTP token binding. And the idea with HTTP token binding is that you want to make sure that the token can only be used within the app that was obtaining the token. Okay? And so this is really promising, because then imagine you have an app and somehow the cross-site scripting steals the access token. And now the attacker, if they've exported it and are trying to use it from some other location, they can't if this HTTP token binding thing ensured that the token could only be used from that particular browser, for example. Okay? So this is actually really promising to solve a lot of problems. Now that we're talking about using code flow from a JavaScript app, we also think about getting potentially refresh tokens. Right? Think if refresh tokens are lost from your app. Those are even more powerful than access tokens, because they can just continue to get new access tokens over and over and over, and it's outside your browser. So refresh tokens in this mode are still very, very dangerous to do. So anyway, this HTTP token binding sounded like it was going to be the solution to the problem, because it really restricted who could be actually using the token. And then unfortunately, I think it was the same month that the token binding specs were actually finished. Google announced that they were removing token binding as a feature from Chrome. Okay? Why? It's not terribly clear. They didn't seem to understand the benefit of it. And it was actually in Chrome, and then they removed it. So not entirely sure why. And I've never seen any justification really since then explaining it. But even other people in Google who work on these specs are trying to, say, please, let's get it back in. Yeah, question.
Doesn't Microsoft browsers support token binding?
I think Edge, are they working on it? Yeah.
Edge does. Edge, but once Edge switches to Chromium.
Yeah. So, anyway. Yeah, so unfortunately, I think because one of the major browser vendors removed it, it means we can't really rely upon it, right? Unfortunately. So anyway, that's kind of a bummer, as we say in the US, right? Okay. So anyway, yeah, this is, again, the whole cross-site scripting, and, it's a hard problem, okay? Now, the other thing that we need to talk about in terms of managing a token is the token renewal. And we talked about, maybe refresh tokens aren't the best approach in these JavaScript apps because of how dangerous they are in that context if they're stolen. So the other approach is this thing called a silent renew, and that's been around as a technique for a really long time for JavaScript applications, which is basically you make the same authorization request back to the token server to get a new token, except you do it in an iframe. Right? That way the user won't see it. That also has the characteristic of the iframe is relying upon the cookie, the session at the token server. So that means that only somebody with that valid session or cookie can actually continue to get new access tokens. So that's actually a nice technique to restrict access, and ensure only that JavaScript app is the legitimate one to continue to get new tokens. Okay. So we have a JavaScript library that implements these protocols. And we've had this now for several years, and it was just around the end of last year where we have updated it to now support code flow with Pixie. Okay, so I have a quick sample of that. Maybe not the most beautiful thing in the world. There we go. So I have this little JavaScript application. What I have here is an HTML page. Okay, it is loading in our OIDC client JavaScript library, and the idea is that we go off and do our normal configuration as a client, and the big thing here is the response type here is code. Okay, so you might have been using this library before to do implicit flow. Really not a big deal. You just update to the latest version and switch your response type, right? Instead of ID token, which was the implicit flow, you can switch over to code, and that's pretty much what you need to do to get your app to do this new flow. Okay? And then what we have is this user manager, which can do a little bit of session management for you and do the protocol work. This session management is provided by a little get user function that can load up and see if the user's has a session in your app. And some helpers, log in and log out, right, to go do the protocol work. Okay? So simply logging in. If I have an internet connection, good. There's my token server, Bob and Bob. And here we go. We got the result, and we came back. And maybe I guess I should have shown that on the network. But if we rerun this, yeah, somewhere in here we should see the word token, right? So the point is we were, in fact, using the token endpoint from the client. And somewhere way down here we should see a code being sent along. Okay? So this is an updated app to use code flow with Pixie. And by the way, there's the code verifier for Pixie. So now we can invoke our API, which is just a matter of loading up the session, getting the user object, getting the access token, and calling that API. The renewal, like I talked about, then supports the ability to renew your tokens, but it does it in the iframe. Okay? So if you hit renew token, I don't know if you can see down here at the bottom, but what we're doing is the library is simply crafting up the iframe, making the request, and getting the result back. Okay, good. All right. Now, there's actually one more topic here in the space of our JavaScript applications. As I've already mentioned, there are all these new specs that are coming out to help with all these features, and then some vendors decide not to implement them. That's a different issue. But one other one is something called SameSite Cookies. Okay? Do you remember the the original problem with our original design of JavaScript apps using cookies to do authentication was the cross-site request forgery attack. Okay? And we needed to do all kinds of mitigations to protect against that. So it turns out that that's exactly what SameSite Cookies is for. It's a new spec from the W3C. It basically extends the features of how cookies work with this new flag called SameSite. So the idea now is that when you render your cookie, or you issue a cookie back to the browser, you can append a SameSite flag, and this tells the browser that the cookie should only be sent back to your app or your API if the page making the request is from the same site. Okay? That effectively kills the attack of cross-site request forgery. Okay? The biggest concern with this, of course, is that it's a fairly new feature. Okay? So it's just in the last 6 months that we're actually kind of getting all the latest browsers caught up with implementing this. But you still have, maybe you have many people running on the prior version of browsers. So, whether or not you want to start depending on this is sort of up to you. Dominick is still a little gun shy of it. That's a good point too. Yeah, the spec is not finalized yet. So, but I'm very confident in this. So, okay. So anyway, that's the idea. What this means is then, wow, maybe we don't need tokens for protecting our web APIs. Okay? Now, that's only going to work if your application is a same-site application, right? The cookie's only going back to the same site. But what if you have APIs that are cross-domain still, but you want to use the same-site cookie? Well, there's a very typical architecture here, which is this BFF architecture, right? It stands for back-end for front-end. So this actually kind of looks like what we might have done 10 or 15 years ago. So imagine what you're going to do is you're not going to have your SPA connect directly to the web API. Okay? What you'll have is you'll have a back-end, right, piece of your application. That will go and do the normal login workflows with OAuth and OpenID Connect. Right? You'll get back your tokens, and then you'll issue cookie in your browser. And all of the calls from your JavaScript are going to go back to your server, your back-end for your front-end, if you will, using the cookie style, right, with our same-site cookies. Okay? And then the back end, because we have a cookie and we logged in with OpenID Connect and OAuth, we could then have our proper access tokens to then call back to the underlying API. So that's another style that you could use. I think we have a lot of people who are interested in this style, because if you think about, all of this JavaScript that you have to write in your application, you're really increasing the complexity in your SPA. So I think that's, depends on your architecture. Depends if you want the SPA to go directly to the API, or if it's, you'd rather deal with sort of the lesser of the two evils, right? In terms of securing the JavaScript from things like, our various attacks, it might be a little bit easier if we have this style. Okay, so it's another option. Okay. So actually, I have a demo of this. Yeah, go ahead. Yep. So the HTTP only flag is a flag. It's been around forever, as far as I could remember, in cookies. And it basically is the flag to tell the browser that you don't want the cookie programmatically available from JavaScript, which in effect, you're relying upon the browser to protect you from like the cross-site scripting attack, at least of stealing the cookie. It's kind of like the same, the token binding, the HTTP binding that we were talking about before. Okay, so we have a sample here. Let me run this, which is now different HTML. Oh, that's not what I wanted. Let me go run my API. So what I have here is another example. I have two projects in my solution here. The first one is basically a standalone API. This is the API that's meant to be the API on the far right on the slide. And this is an API that is only going to receive access tokens. Okay? So I have this running. At least I think I have it running. Okay? And then over here in my host, this is now the application that has a combination of the back end for front end, if you will, right? So we're going to do normal OpenID Connect over to our token server, but we're going to then have some endpoints in here that are going to be protected for using cookies. Okay, those are going to be invoked by our AJAX code, and those will do something like maybe just be the features, the APIs that are needed to serve up to our front end, okay? But you may have, again, some features that can be implemented at this point and some features that actually need to be sent all the way, okay, depending on what type of API you need to call. So you need something else in this back end for front end that could do things like proxying, right? Basically proxy the request all the way over. So there's another piece in here, which is a open source project called ProxyKit, I believe. It basically allows you to run a reverse proxy as middleware in your ASP.NET Core application. So the idea is that maybe some endpoints go just to my BFF, other endpoints go to these proxy endpoints, and they get proxied over to the actual API. When I'm doing the proxying from the browser to my BFF is using the cookie, and then when we hit this particular reverse proxy, notice it's actually extracting the access token from my cookie, and then using that to call to the actual backend. So that's basically, if I rerun this, that's basically what this is doing. So I'll log in with Bob and Bob. Okay, so this first button here, basically when I invoke this, this is just going one hop, right, to the first API call, and this is then simply using my my BFF cookie that I have. Okay, this just happens to be hitting a different path in the application, which actually then routes all the way over to the other guy, and that's using the access token, and you can see then the return here is actually showing you everything that was in the access token. So again, for the first hop, same idea, it's using the cookie, but for the second hop, it's using the access token. So there's a sample application that shows you, how that approach could work. Okay, so here's a list of lots of reading, right? This is homework for you now that we've come to class for an hour. You can go home and read up on all these sort of latest and greatest things from the spec committees and all these other things from the W3C. So that's there for you. And other than that, we have some stickers if you'd like some identity server stickers, but other than that, that's it. Thanks.